This is Math 6, Lesson 4-9, Fractions and Decimals. A terminating decimal is a decimal that stops or terminates. For example, 0.5 or 1.2136. A repeating decimal is a decimal that repeats the same digits or group of digits. For example, 1.3 repeating, or 1.273527352735, and three little dots after it means it keeps going and going and going from with that pattern, 27352735. That's a repeating decimal. We're going to learn today to convert between fractions and decimals because those are very, very important skills to be able to do when you want to compare numbers. So, to convert a decimal to a fraction, you find the place value of the very last digit. You write that number over the place value and reduce if possible. For example, in the decimal 8/10ths, I look at this place value right here. The 8 is in the tenths position. So I literally write it as 8/10ths. And then I reduce this. I know that 8 is divisible by 2, and 10 is divisible by 2, and it reduces down to 4/5. So 4/5 is the fractional equivalent of 0.8. If I have 0.125, the 5 is in what place value? It's 10 hundredths thousandths. The 5 is in the thousandths position because this is 125 thousandths. So I'm literally going to write it as 125 thousandths. That's the first thing I do. Then I need to reduce this fraction. Well, I know for a fact that both of these are divisible by 25. Okay, so I'm going to take and divide these by 25. 25. Okay, 25 will divide into 125 5 times. And 25 will divide into 1,000 40 times. And I'm looking at 5/40ths and going, oh, 5/40ths also reduced, so I can divide that by 5, divide this by 5, 5/40ths becomes 1/8. So 0.125, or 125 thousandths, is a fraction, is 1/8. 1.32. Okay, this is 1 and 32 hundredths because this is in the hundredths place. The 2 is in the hundredths place, so this is 1 and 32 over 100. So the 1 can stay, but I need to reduce the 32 hundredths position. So I'm just going to take the 32 over 100, and I'm going to reduce that. Okay? I know that 32 is divisible by 4, and I know 100 is divisible by 4. Okay? 32 divided by 4 is 8, 100 divided by 4 is 25. So 1 and 32 100ths reduces to 1 and 8/25ths, and 1 and 8/25ths is the fractional equivalent of 1 and 32 hundredths, or 1.32. 3.375. Okay, that means this is 3 and 375 thousandths. 375 thousandths, because 0.375 is 375 thousandths. So now I need to reduce this. Okay? I know it's divisible by at least 25, because 25 is a nice number to divide most things by. So this becomes 375 divided by 25. Okay, if you don't know that, take 375 down here and divide it by 25. 25 goes into 37 one time. So 1 minus 5 is 2, 3 minus 2 is 1. 125. 25 goes into 125 5 times, so this goes down to 15. And 25 goes into 1,040 times. But 15 over 40 reduces. I can reduce that. 5 goes into 15 3 times. 5 goes into 40 8 times. So 3 and 3/8. Okay, the better you can reduce your fractions, the easier these problems will be. But they're not hard. You just look at the place value of the last digit, and that place value becomes the denominator of your fraction. The place value of this 8 was in the tenths, that became our denominator. Place value of the 5 was in the thousandths, that became our denominator. Place value of the 2 was the hundredths, that became our denominator. Place value of this 5 was the thousandths, that became our denominator. Writing as a fraction as a decimal. To convert a fraction to a decimal, You divide the numerator by the denominator. In other words, divide the bottom into the top. Just like when we did it converting improper fractions to mixed numbers. You're still dividing the same numbers. We divide the bottom number into the top number, and you place a bar over any group of digits that repeat, if that's necessary. So if I have 13 twentieths, I'm going to divide 20 into 13. I'm going to have to add a decimal point and probably a couple of zeros. Who knows how many zeros? Depends on how long it takes to divide it out. Okay? 20 does not go into 13, but 20 will go into 130. Think about it. How many times will 20 go into, or 2 go into 13? It goes in about 6 times. So 6 times 20 is 120. 130 minus 120 is 10. Bring down my other 0. 20 goes into 105 times. 5 times 20 is 100. So 13 twentieths as a decimal is 0.65. 1/6, again, same process. You divide the bottom number into the top number. Notice I'm going to need to add some zeros. Okay, so I need to add several zeros here. Bring my decimal point straight up. 5 does not go into, or 6 does not divide into 1. 6 divides into 10 one time. 1 times 6 is 6. 10 minus 6 is 4. Bring down my 0. 6 goes into 40 6 times. 6 times 6 is 36. 40 minus 36 is 4. Bring down my 0. Wait a second. This is the same as this, which means it's going to repeat, isn't it? 6 times 6 is 36. Oh, look, it's repeating again. So basically, I can stop dividing now and tell myself this is 0.16, and the 6 is the only digit that's repeating. You only put a bar over the digit that is repeating. Let's look at some mixed numbers. Now, mixed numbers can be done in one of two ways. Okay? You can convert the mixed number to an improper fraction, which is what I highly suggest you do, because otherwise you forget the whole number part. This is typically what happens when people don't convert it into an improper fraction. I have some people that like to just work with the fractional part of it, but I tell people that's probably not a good idea. So we're going to change it to an improper fraction. So a times 2 plus 2 all over 8. 8 times 2 is 16 plus 2 is 18, so we have 18 eighths. So take 8 and divide it into 18. 8 goes into 18 twice. 8 times 2 is 16. 8 minus 6 is 2. Bring down my 0. 8 goes into 20 twice. 8 times 2 is 16. 20 minus 16 is 4. Bring down my 0. 8 goes into 45 times. 5 times 8 is 40. I have no remainder. This is a terminating decimal. Okay, and my terminating decimal is 2.25. Some of you may have known that because you may have looked at this and said, oh wait, 2 and 2/8 is 2 1/4, and 1/4 is 0.25. So you may have been able to do this in your head, but if you couldn't, this is how you can do it. Okay? 1 and 2/9 probably can't do in your head, because most people don't know what ninths are in decimal forms. So 1 times 9 plus 2 is 11 ninths. So I'm going to take my 9 and divide it into 11. 9 goes into 11 one time, with 2 remaining. I bring down my 0. 9 goes into 20 twice. 9 times 2 is 18. Bring down my 0. Wait a second. 9 goes into 20 twice. 18. I see some I sense a pattern here. I realize that this 2 is going to continue to repeat. So I already know then that this is a repeating decimal with 1.2, and my 2 is my repeating part of my decimal. So the answer to this is 1.2 with a bar over the 2. The last thing you need to be able to do is compare groups of fractions and decimals. And I will tell you, it is probably easiest to take, when you're comparing and ordering a list of numbers that contains both fractions and decimals, it's probably helpful to rewrite them, all the fractions, as decimals, rather than trying to put the decimals as fractions, because then as soon as you get them as fractions, you still have to find common denominators. So it is much easier to convert the fractions to decimals than it is the decimals to fractions. So in this list, 3 and 2/5, or excuse me, 2 and 3/5, 3 and 1/5, 1.8 and 2.7, I'm going to take these two fractions right here, and I'm going to convert them both into decimals. So 2 and 3/5 is 13/5. 5 goes into 13. 5 goes into 13/12 twice, which is 10. 3, bring down my 0. 5 goes into 36 times. So 2 and 3/5 is 2.6. Okay. Then let's look at 3 and 1/5. 3 and 1/5. That is 16/5. 5 goes into 16. 3 times 5 is 15. 3 goes into 5 goes into 10 twice, so that's 3.2. So I now have the following numbers. I have 2.6, 3.2, 1.8, 2.7. So the smallest number out of all of these is this one, 1.8. Then we have the 2.6, then we have the 2.7, and last we have the 3.2. But remember, when we order things, we have to put them back in their original form. So if I look at this problem, I have to list it in its original form. So the smallest number is 1.8, and that was a decimal, so we can write it in decimal form. The second was 2.6, but that is equivalent to 2 and 3/5, so 2 and 3/5 is how we'll write that second number. The third number is 2.7 as a decimal, and the fourth number is 3.2, but its fractional original problem was 3 and 1/5. So in order from least to greatest, the numbers would go 1.8, 2 and 3/5, 2 and 7/10, 3 and 1/5. And that's converting fractions to decimals and decimals to fractions.